Bonjour and good morning. Welcome to WASA Distance Education and PLAR Math. And this is week 3 of classes in term 1B. And so we have, after this week, 3 more weeks of classes before the Christmas break. So of course that means try to get as much work finished as you can before the Christmas break and get it sent out for marking. So we are in term 1B now, so PLAR students who didn't finish what you were working on in term 1A, you can continue working on the key questions in this term, so you're not withdrawn. Just keep working from where you left off. So once you apply for PLAR for the school year, you are in the school year until the school year ends. So you're not withdrawn, just keep working and continue to submit your work. Participating in classes are 2 ways. One way is on radio, so call into our studio, and the other way is using Zoom. And so you can use in your study guide the link provided, or you can follow the instructions again in your study guide for joining the class. You can also ask your DEC or contact me for help with joining the classes. So all PLAR Math students, doesn't matter how you signed up for PLAR, IL, or Radio Zoom, you're welcome to attend the live classes. And also the recorded classes are uploaded to YouTube, so you can watch those classes if you need help as well. To contact me, you can use email, phone, or send a message on Facebook. Whatever works best for you. PLAR English classes from last term are available on YouTube. So you can either go to my YouTube channel, B. Osmond Wasa, and also the Wasa Distance Education Center channel. All of the classes, all of the WASA classes are uploaded there, so you will find the PLAR Math that we're doing right now, and you will also find the PLAR English from last term on the WASA YouTube channel, as well as on my channel. So I'm leaving both there until I get all of the PLAR Math classes uploaded so that students can use both on the WASA YouTube channel. So for now, if you want to watch the PLAR English classes, you can use my YouTube channel or the WASA Distance Education Center channel. For the PLAR Math, only the new classes are uploaded on the WASA Distance Education Center channel, so you can watch the old classes on my YouTube channel. So if you're working ahead of where we are now and you need help with something that we're not working on yet, you can watch the classes from last year on my YouTube channel. Okay, just a couple of reminders. So PLAR students who didn't finish in 1A can continue working on the key questions in 1B. I've mentioned this several times, but new this year, so starting in September, all PLAR students have the option of writing the culminating activity instead of doing the lessons and key questions. And that's even if you have already completed and submitted some of the key questions. So if you've started on the lessons and the key questions, you still can switch to writing the culminating activity instead of finishing the lessons. If you pass the culminating activity, you get your missing credits. Missing grade 9 and 10 credits for that subject, and you don't have to do the lessons and key questions, and you can just move on to the next subject. If you're not successful with the culminating activity, so if you don't get a 50% or better, then you have to go through the lessons and complete the key questions, and then you write another culminating activity after the work in the lessons is finished. So it's not, like I mentioned before, it's not a one and done. It's not that you get only one chance to finish the culminating activity. You get several chances. So don't give up if you fail the first time. Keep at it. Okay, in your lessons, if you're doing the lessons, there are 2 types of questions, the support questions and the key questions. So everything you need to know, to be able to do, everything you need to know in order to be able to do the key questions is in your lessons. So there's no extra textbook or anything like that. The support questions are scattered throughout the lessons, and they're there for you to get practice before you do the key questions. Okay, so you'll read a section, then there will be a support question. Do that support question. Near the end of the lesson, you will find answers to the support questions. So go there, check your answers against the answers that are there. If you're getting most of or all of the questions right, then you move on to the key questions at the end of the lesson. So all of the key questions are at the end. You can just pull those off and send them out to me for marking. The key questions have marks. The support questions do not. So when you see the support questions, you'll notice that there are no marks because I don't mark them. You check your answers yourself. The key questions have marks because I mark them and give you a percentage. So only the key questions are to be submitted for marking. Start working on the key questions right away and submit them as you finish them. Don't wait until you finish everything. Okay, ways to submit your work. First way is to give it to your DEC, and your DEC will send it out to us here in Sioux Lookout. If you don't have a DEC or your learning center is closed for whatever reason, you can submit your own work. Several ways of doing that. So the first way, if you have access to a scanner, you can scan and email your work to studentwork@nnec.on.ca and make sure you CC it to me, or you can fax it to our toll-free fax number if you have access to a fax machine. If you are submitting your own work, be sure to write your name, the subject, and the teacher's name on your work so that we know who completed the work and who it's going to. Okay, the most important thing is your name so that we know when we get it, we can figure out which subject, which teacher it is because of the subject, but if your name is not on it, we don't know who sent the work in, so we don't know who to return it to. So make sure that your name is on it. Okay, if you don't have access to a scanner or fax machine, then you can use your smartphone. With your smartphone, you can either take photos of your work, or you can scan your work using the built-in scanner on your phone, and then you can email it to that same address, studentwork@nnec.on.ca, and make sure you CC it to me, or you can send it using Facebook Messenger. Okay, the scan or the photos can be sent using Facebook Messenger. There are also a couple more options. If you live in Sioux Lookout or the surrounding area and you come to Sioux Lookout, once a week or maybe even once every couple of weeks, then you can use our outdoor mailbox, which is located in the parking lot of the WASA building on the side toward the post office. Or if you want to, you can knock on the door and give it to whoever answers the door. There's also an option of using Google Docs, so you can do your work using Google Docs, and then you can share the link with me so that I can see it and I can mark it. And then of course you can use Google Classroom as well. So Google Classroom is paperless. You can do your work and submit it all online. Okay, so lots of ways to submit your work. And just a reminder that at the end of every term we have a draw, 2 student draws as a matter of fact. One is for students who earned a credit and one is for students who submit work. So if you do both, if you submit your work and you earn your credit, you get your name in 2 draws. So you have a chance of winning 2 prizes. So be sure to submit your work to your teacher to be entered into the draws. And for lessons, for every lesson that you submit, you get an entry into the draw. So if you submit 5 lessons, then you get 5 chances to win that prize. And then the culminating activity on top will give you a chance to win a different prize. Okay, so let's get into it then. So we're going to start off with a review of what we did in our class last week on Thursday. So we started last week talking about fractions. We finished with integers. We talked about adding. We practiced how to add, subtract, multiply, and divide integers. Be very careful, especially when you're working with negative numbers. That's where people tend to make mistakes. So be very careful with the negative numbers. Okay, and then once we finished with integers, I believe on Thursday, we started talking about fractions. So there are different types of fraction. The thing that you need to remember about fractions is that there are two parts to a fraction. There's the numerator, which is the number on the top, and the denominator, which is the number on the bottom of the fraction. Okay, based on these, different types of fractions can be defined. So the different types of fractions, first of all, we have a unit fraction. And a unit fraction is a fraction that has a numerator of 1. So, for example, 1/7. Another example would be 1/10, 1/39, 1/3. Okay? Because they have a 1 on the top, they are called unit fractions. Okay? Then we have proper fractions. A proper fraction has a numerator that is less than the denominator. So that means the number on the top is smaller than the number on the bottom. So in the fraction 2/7, 2 is smaller than 7. So the unit fractions are also proper fractions. So 1/7, 1/10, 1/39, whatever. 3/4 is a proper fraction. 7/9 is a proper fraction, all because the numerator is smaller than the denominator. Okay, then we have improper fractions. So im is a prefix which means not. So basically, improper fractions are not proper. So these are fractions in which the numerator is more than or equal to the denominator. So for example, 5/3. The numerator is bigger than the denominator 3. 5/3. So 7/4 is an improper fraction. 11/9 is an improper fraction. 3/3 is an improper fraction. They're the same. Okay, so the 3 on the top, 3 on the bottom, they are the same, so that makes them improper fractions. So if the numerator is bigger or equal to the denominator, they're improper. Then we have what's called mixed fractions. Sometimes they're called mixed numbers. Okay, they're the same thing. So if you hear mixed fractions and somebody else says mixed numbers, it's the same thing. It's the same idea. So a mixed fraction or a number has a whole number along with a proper fraction. So for example, 8 2/3. So we have the whole number 8 and we have the fraction 2/3. So another example, 1 1/2. We've got a whole number and we've got a fraction. 3 3/4. We've got a whole number and we've got a fraction. And it's a proper fraction. Then we have what's known as like fractions. Like fractions are fractions with the same denominator. So 1/4 and 3/4, they both have a 4 as the denominator. Doesn't matter about the top number. It's only the denominator in this case that matters, that makes them like fractions. So if we had 5/8 and 3/8, they have the same denominator, so they're called like fractions. We also have unlike fractions. And unlike fractions are fractions with different denominators. So 1/3 and 3/4. 2/5 and 1/5. 1/6 are unlike fractions because they have different denominators. And then we have equivalent fractions. We're going to be looking at equivalent fractions today. And actually possibly like and unlike fractions. So equivalent fractions, so equivalent basically means equal. So fractions that have the same value after being simplified or reduced. And we're going to be looking at reducing fractions today. So 6/4 and 12/8. When we reduce those fractions, they actually are the same amount. So I'll show you how that works. So draw 2 circles, or 4 circles, sorry. So this top is a representation of 6/4. So the bottom number, remember, tells me how many pieces to divide my circles into. So each one is in 4s, 4/4, sorry. So then 6/4 would be this much of those two circles. So 4 plus 2. Okay. 12/8, my circles will be divided into 8ths. So both circles will be divided into 8 equal pieces. And then I'm going to color in 12 of those 8 pieces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so those diagrams of 6/4 and 12/8, when you look at them, they're the same. They're both one whole circle and a half of the other circle. So 6/4 and 12/8 are both the same as 1 1/2. It's just that the pieces are smaller, but when you draw a diagram and look at it, they're the exact same. They represent the exact same fractions. Okay, so then after we talked a little bit about what fractions are, then we looked at changing a mixed number to an improper fraction. So a mixed number, remember, same thing as a mixed fraction. So our mixed number is 2 3/4. So to change a mixed number into an improper fraction, we multiply the whole number and the denominator. So 4 times 2. And then we add the numerator. So plus 3. So 4 times 2 is 8. 8. Then we add the 3. 8 plus 3 is 11. And this is all over the same denominator. So that 4, that denominator 4, doesn't change. So that's why all of this is written over the denominator 4, because the denominator is not going to change. It's only the numerator that changes. And then we also looked at how to change an improper fraction to a mixed number. So remember, an improper fraction has a numerator that's bigger than the denominator. So 14/3. So to change an improper fraction to a mixed fraction or a mixed number, we need to divide. So for mixed number to an improper fraction, we have to multiply and then we have to add. To change it, go back the other way, we divide. So 14 divided by 3. So as I mentioned, you can do this on your calculator. So if you do it on your calculator, you get 14 divided by 3 equals 4.66, and that 6 repeats, so I'm going to round it to 667. Okay, so if you use your calculator, 14 divided by 3 equals 4.667. 4 will be the whole number, so 3 will divide into 14 4 times evenly. And then there's this part left over. Well, I don't want a decimal for my answer. I want a fraction. So in order to figure out what the what's left over, what the remainder is, then I'm going to take that 4 and I'm going to multiply it by 3, which gives me 12. And then 14 take away 12 equals 2. So my numerator is 2. My denominator stays the same, 3. So 4 2/3 is my answer. So that's how you can find your answer using a calculator. Or you can do long division. So how many times does 3 divide evenly into 4? So 3 divided, that's not 4, sorry, 14. 3 divides 4 times. 3 times 4 is 12. Then I subtract 12 from 14. 14 take away 12 is 2. 2 is my remainder. My remainder, 2, becomes the numerator of my fraction. The whole number 4 becomes the whole number of my mixed fraction, and the denominator 3 stays the same. So 4 2/3. So whichever way you do it, you should get the same answer. So whichever way makes more sense to you. But again, when we're changing from an improper fraction to a mixed number, we do not want a decimal. We want a fraction in our answer. So if you're using a calculator, you still have to have a fraction as the fraction part of your answer. All right. So that's what we've done so far with fractions. So today we're going to continue on. So as I said, we've done adding, subtracting, multiplying, and dividing integers. And we talked about fractions. So today we're going to look at reducing fractions, and if we have time, adding and subtracting fractions. So in your lesson, beginning on page 20 is information on equivalent fractions. So read through that information and the examples, and then on page 21 is support question number 7. Do that support question, then check your answers at the end of the lesson. Okay, so what are equivalent fractions? So equivalent fractions are fractions with different numbers representing the same part of a whole. So like I showed you before when we're talking about the different types of fractions, when we talked about equivalent fractions and I drew the pictures. So they represent the same part of a whole, but they have different numbers. So they look different, but when it comes to the value, they are the same. So they have different numerators and denominators, but their fractional values are the same. So for example, think about the fraction half. It means half of something. So everybody knows what a half is. You can also say that 6/12 is half and 50/100 is half. They represent the same part of the whole. These equivalent fractions contain different numbers, but they mean the same thing. So a half equals, 6/12, which also equals 50/100. So here we go. Some pictures to show you what I mean. So here's a half. So it's a whole circle cut into 2 pieces. So remember the bottom number tells us how many pieces are in the that we're cutting the whole into. So we've got a whole circle cut into 2 pieces. 2/4 is equal to a half. So we take a whole circle, we cut it into 4 pieces, 4 equal pieces, and we shade 2 of them. So here we have the same amount of shading. 3/6 is also equal to a half. So take a circle, cut it into 6 equal pieces, and shade 3 of those pieces. 4/8 is also equal to 3/6, 2/4, and 1/2. So we take a whole circle, divide it into 8 pieces, and then we shade 4 of those 8 pieces. So in each one of these diagrams, we actually have a half. So a half is equal to 2/4, which is equal to 3/6, which is equal to 4/8. And we can keep going. We can keep drawing a circle and dividing it into more and more parts. And then they'll still be equal to a half. Okay, here's another example with a cake. So Ruiz ate 1/3 of his cake. So 1/3 means that the cake is divided into 3 equal pieces, and he ate 1 of those 3 pieces. Liam ate 2/6 of his cake. So we have a cake that's divided into 6 equal pieces. So each piece is 1/6. Liam ate 2 of those 6 pieces. Okay, so 1/3 is the same as 2/6. And Noah divided his cake into 9 pieces, and he ate 3 of the 9 pieces. So 1/3 equals 2/6, which equals 3/9. So even though the numbers are different, it's the same amount of cake. So 1/3 equals 2/6 equals 3/9. So they all ate the same amount. Even though 3/9 sounds like more because there's 3. It's the same amount. Here's another example with chocolate bars. So take a chocolate bar, break it into 4 equal pieces. So if you look, they're all the same. 2/4, 2 of those equal pieces. Same chocolate bar, but now we're breaking it into 16 pieces. Okay, so each piece has 2 blocks in it. 8 of those 16 pieces is the same as 2/4. Same chocolate bar, this time breaking it into 8 pieces and separating 4 of those 8 pieces. Same chocolate bar, breaking it into 32 equal pieces. So each little square on its own, taking 16 of those 32 pieces, and it's still, all of these represent a half of the chocolate bar. Okay, so if you look at them, it's every one of them, even though they're different numbers, they all represent a half of that chocolate bar. So 2/4, 8/16, 4/8, 16 32s, or 32nds. They're all half of the chocolate bar. They're just broken up into different pieces, different numbers of pieces. So that's what equivalent fractions are. So they have different numbers, but they have the same value. So think of it in terms of value rather than pieces. So when we are adding and subtracting, multiplying, just adding and subtracting fractions, not multiplying, dividing. When we're adding and subtracting fractions, we need sometimes to find equivalent fractions. So that's why I'm talking about equivalent fractions. So in order to use equivalent fractions, you have to know how to find equivalent fractions. To do that, you have to multiply both the numerator and the denominator, both parts of the fraction, by the same whole number. As long as you multiply both the top and the bottom of the fraction by the same number, you won't change the value of the fraction, and you'll create an equivalent fraction. If we multiply the top by one number and we multiply the bottom by a different number, then we have created a whole new fraction. Okay, it's not equivalent. So just remember, top and bottom need to multiply by the same number. So here's an example. Find the equivalent fractions to 3/4 by multiplying the numerator and the denominator by the same whole number. So 3 times 2, 4 times 2, multiplying both by the same number, equals 6/8. 3 times 2 is 6, 4 times 2 is 8. 3/4, multiply the top by 3 and the bottom by 3. 3 times 3 is 9, 4 times 3 is 12, 9/12. 3/4, multiply both top and bottom by 4, we get 12/16. 3/4, multiply both top and bottom by 5, we get 15/20. 3/4, multiply top and bottom by 6, we get 18/24. So these fractions, are all equivalent fractions. 3/4, 6/8, 9/12, 15/20. So if you want to, you can draw pictures. So first fraction, 3/4. Circle is divided into 4 pieces, 3 are colored. Second fraction, 6/8. Circle is divided into 8 pieces, and we are coloring 6 of them. So 2, 4, 6. Next one, 9/12. This is not going to be equal, but imagine that it is. 2, 4, 6, 2, 4, 6, 8. I don't have enough. Still's not equal, but anyway. 2, 4, 6, 8, 10, 12. So then I'm going to 2, 4, 6, 8 twelfths. Should be the same, but it's not. Close. Okay, so if we took them and divided them evenly, then they would represent all the same amount. Okay, I gotta try that again. 4. Oops. All right. And then 9/12, so 3, 6, 9/12. There we go. Okay, that's better. So they represent the same amount. So basically they all represent 3/4 or 3/4 of the circle, even though the numbers are different. The value is the same. The amount is the same. Okay, so note that if you reduce all of these fractions to lowest terms, they equal 3/4. So that's what we're going to be looking at, is reducing fractions. Okay, so reduce fractions to lowest terms. So we reduce fractions to lowest terms because it makes adding, subtracting, multiplying, dividing easier to work with. Okay, so we're working with smaller numbers, it's easier to do anything. So reducing fractions to their lowest terms involves division. So we have to divide. So our fraction 30/36. Okay, it's big numbers to work with there. So if we have to add that to something else, you got big numbers. So it makes it easier if we can reduce it. So there's a bunch of different, or I shouldn't say a bunch of different, there's 3 different methods for reducing fractions. So method number 1, and you use whichever method works best for you. Method 1 is to find the common factors. It's a slow and steady method, so it takes some time. So you got to ask yourself, do 30 and 36 share any factors other than 1? Because if we divide 30 by 1, we get 30. We divide 36 by 1, we get 36. So that makes no difference. That changes nothing. So other than 1. So the factors, remember, are the numbers that we multiply to get our product. So the factors of 30 are, so we can multiply 1, which we're not going to bother with because that's no good. So 2 times 15 is 30, 3 times 10 is 30, 5 times 6 is 30. So those are our factors of 30. We're not using 30, we're not using 36. So the factors of 36 are 2 times 18 is 36, 3 times 12 is 36, 4 times 9 is 36, and 6 times 6 is 36. We're just going to put 6 there once. So we've got a lot of factors that are the same. So we've got 2, we've got 3, we've got 6. So 2, 3, and 6 can all divide evenly into 30 and 36. So they have common factors. So now, what are we going to do? We're going to divide by their lowest common factor, which is 2. So 30 divided by 2, 36 divided by 2. 30 divided by 2 is 15, 36 divided by 2 is 18. So we've reduced 30 36ths to 15 18ths. So now, do you think that's as low as it can go? Well, let's see. Let's see if 15 and 18 share any factors other than 1. So the factors of 15 are 1, which we won't use, and 15 and 18, which we won't use. So 3 times 5 is 15. Factors of 18 are 2 times 9, 3 times 6. So do we have anything in common? Yes, we have 3. So they're both divisible by 3. So we divide 15 by 3 and 18 by 3. 15 divided by 3 is 5. 18 divided by 3 is 6. Are we done? Can we reduce 5/6 any further? No, we can't. Okay, 5/6 is as low as it will go because 5 is a prime number. Okay, the only numbers that divide evenly into 5 are 1 and 5. And the factors of 6 are 1, 2, 3, and 6. So the only thing they have in common is 1, and 1 is no good. So that's as low as it can go. 5 and 6, 5/6 is lowest terms. Okay, so that's method number 1. Method number 2 is finding the greatest common factor. So same thing we just did, basically. This is a little bit faster. So we take 30 and 36. We find the factors of 30, which we already did, the factors of 36, which you already did. So we said 2 and 2, 3 and 3, 6 and 6. So in this case, the greatest common factor is 6. So instead of last time when we multiplied by 2, this time we're going to multiply by the biggest number that will divide evenly into both, and that's 6. So 30 divided by 6 is 5, 36 divided by 6 is 6, and our answer is 5/6, which is what we ended up with last time, 5/6. So this time we cut out a few steps. We did it more quickly, more efficiently. Only took us one step because we used the greatest common factor. Okay, method number 3 is prime factors. So a prime factor, a prime number, is a number that's divisible by only one and itself. So another way to reduce fractions is to break the numerator and the denominator down to their prime factors and remove every prime factor the two have in common. So again, we're using 30 36. So the prime factors of 30 are 2, 3, and 5. So 2 times 3 times 5. 2 times 3 is 6. 6 times 5 is 30. The prime factors of 36 are 2 times 2 times 3 times 3. 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 36. So here are our factors. 30 is 2 times 3 times 5. 36 is 2 times 2 times 3 times 3. So now what we do is we cross out the ones that they have in common. So 2 and 2, 3 and 3. So then we're left with 5. Oh, we'll go down here. We're left with 5 on the top and 2 times 3 on the bottom. 2 times 3 is 6. So 5/6. So same answer, but 3 different ways of doing it. Okay. You do, like I said, whichever way makes the most sense to you. It doesn't matter. I'm not going to mark it wrong because you used a different method than I use, for example. Okay, so again, you use whichever method works better for you. As long as you get the right answer, it doesn't really matter. And in some cases, you can do it in your head. Okay, so some people who are good with math, good with multiplying and dividing, you can just look at it and you can reduce it. You don't have to write anything down. For people who are have a little bit of trouble with reducing fractions, then you choose whichever method works best for you. Method 1, method 2, or method 3. Okay, so some tips and tricks for reducing fractions. So some things to keep in mind. If either numerator or denominator of a fraction is a prime number, then the fraction cannot be simplified further. So if the number on the top, okay, so if it's a 3, 3 is only divisible by 3 and 1. If it's a 5, 5 is only divisible by 3 and 1. 7 is only divisible by 3 and 1. 11 is another one that's only divisible by, Okay, 3 is 3 and 1. 5 is, I think I said 5, 3 and 1 every time. 5 and 1. 7 is 7 and 1. 11 is 11 and 1. 13 is 13 and 1. So these numbers, 3, 5, 7, 11, and 13, are all prime numbers. And there are more, but I'm not going to list them all. Okay, so if you have one of those numbers in your numerator, the fraction can't be reduced any lower. Numerator or denominator. Number 2, a fraction that has 1 in the numerator cannot be reduced further. So, 1/3 can't be reduced. 1/10 can't be reduced because 1 can't get any smaller. Number 3, to reduce an improper fraction. So remember, an improper fraction is a fraction that has a bigger number on top. So to reduce an improper fraction, first we write it as a mixed fraction and follow the same method of simplifying a proper fraction. So I won't use 14/7 actually, because I'm going to end up with a whole number as my answer. So let's say 8/3. Okay, so 8/3, I need to change that to a mixed fraction first. So 3 goes into 8 twice with a remainder of 2, so 2 2/3. Oh, that one's not a good example either because I can't reduce the fraction there. So I change that to an improper fraction first, or mixed number first. Then I have to look at my fraction and see if that can be reduced any lower. And if it can, I have to reduce it. If it can't, I leave it as that. Okay, we'll do some other examples later on. Okay, number 4, for finding factors of numbers in the range 1 to 120, it suffices to check divisibility by 2, 3, 5, and 7. So any number from 1 to 120, if you are trying to factor that out, trying to find the common factors, using any of these numbers, 2, 3, 5, and 7. Okay, so 100, so even if it's 120 divided by 5. So try 1. So in the example, 24/73, 2 divides evenly into 24, but not 73. So that means 2 is out. 3 divides into 24, but not 73. So 3 is out. 5 doesn't divide evenly into either. Finally, 7 doesn't go into 24. So the fraction is already reduced to lowest term. So even though it's a big number, 24/73, it can't be reduced any lower. Okay, the reason for this, if any number 1 to 120 factors as m times n, so any number times a number, then the smaller of m and n must be less than 11. Otherwise, the number would be at least 11 times 11, which is 121. So if the number is composite, so made up of another number, the smallest factor must be a prime less than 11. So that's why we try to divide by 2, 3, 5, or 7. So if the number is 120 or less, we only have to try dividing by one of those 4 numbers. Checking divisibility by 2 and 5 is easy, so start with those. Okay, dividing by 2 is easy. You divide it in half. Same thing with 5. To check 3, you can add up the digits and see if that's divisible by 3. For example, 123 is divisible by 3, since 1 plus 2 plus 3 equals 6. And 6 is divisible by 3. Divisibility by 7 is harder to check, but you could use long division and see if you get a remainder. 73 is 3 more than 70, so the remainder here would be 3. Okay, oops, did I finish that? Yeah. Okay, so try this math hack for simplifying 96 over 104. So another way, subtract to get the difference between the numerator and the denominator. So 104, the denominator, take away the numerator. So 104 take away 96 is 8. So the difference 8 is the upper limit for any numbers that can possibly go into both 96 and 104. So no number higher than 8 will divide evenly into 96 and 104. In other words, the difference is the largest possible greatest common factor. So does 8 go into both 96 and 104? So let's try it. 96 divided by 8 is 12. 104 divided by 8 is 13. So state the answer. 96, I'll write it this way, 104ths is equal to 12/13. So we've just reduced that. So now 74/80ths, so subtract. 80 take away 74 will give us 6. So 6 is the largest number that can possibly divide into both 74 and 80. Does 6 go into 74 and 80? No, it goes into neither one of them. So 74 divided by 6 won't give you a whole number. 80 divided by 6 won't give you a whole number. But it tells us that the only numbers that can possibly go into both 74 and 80 are the factors of 6, which are 6, 3, and 2. So then you divide 74 and 80 by 3, see if that'll work, or by 2. Okay, so does 3 go into 74 and 80? No, it doesn't go into either one. But now you know that it's got to be 2. So does 2 divide evenly? Yes. So 72 divided by 2 will give you 37. 80 divided by 2 will give you 40. So 74/80ths is equal to 37/40ths. And you've reduced it as far as it will go. So that's a trick to help you reduce fractions. So subtract the numerator from the denominator, and that will give you the greatest factor that can divide into both. Try that. If that doesn't work, then you find the numbers that multiply the factors of 6 or whatever the number is, and then try those. Okay, so simplify the fractions. A little bit of practice here with simplifying fractions. 6/30ths. Okay, so another trick to try when you're reducing fractions is ask yourself, does the numerator, so the numerator is the number on top, divide evenly into the denominator? So, and this one is the one that I usually go with first. So 6/30ths, 6 divided by 6, 30 divided by 6. So 6 divided by 6 is 1, 30 divided by 6 is 5. So it reduces to 1/5. So again, check the top one. Does 5 divide evenly into 10? Yes, it does. 5 divided by 5, 10 divided by 5, 5 divided by 5 is 1, 10 divided by 5 is 2. So when you have a small numerator, check and see if it will divide evenly into your denominator. That's probably one of the quickest things to do. So 4 divided by 4, 10 divided by 4, 4 divided by 4 is 1, 10 divided by, or 40 divided by 4 is 10, 1/10. So once you get 1 as your numerator, you know that's as low as you can go. Okay, so number 4, 24/30ths. Now this one, I can look at it because my math is pretty good and I can figure out what it is. But if you wanted to try that method of 30 take away 24, okay, so denominator take away numerator equals 6. So then I'm going to see if 24 divides by 6, and it does, and 30 divides by 6, and it does. 24 divided by 6 is 4, 30 divided by 6 is 5, and there's my answer, 4/5. Okay, so subtract and then divide. Number 5, 6/8. I can do this even though these are small. Well, I know that 6 won't divide evenly into 8. I can do 8 take away 6 equals 2, and then 6 divided by 2, 8 divided by 2, 6 divided by 2 is 3, 8 divided by 2 is 4, and my answer is 3/4. Okay, let's look at this one here. 99 108. So let's subtract. 108 take away 99 equals 9, right? Yeah. So now 99, is that divisible? I know 99 is divisible by 9 because 9 times 11 is 99. But what about 108? 108 divided by 9 equals, whoops, try that again. 108 divided by 9 equals 12. So my answer is 11/12. Okay, so those are a few methods that you can use to reduce fractions. So again, look at your top number. Does it divide evenly into your bottom one? If it does, just divide by your numerator. So 4 divided by 4 is 1, 8 divided by 4 is 2. There's my answer. Bigger numbers, 63 72s. 72 divided by 63 equals 9. 63 divided by 9 over 72 divided by 9. 63 divided by 9 is 7. 72 divided by 9 is 8. So reduced terms is 7/8. So whenever you are doing your final answer, so key question 6, reduce fractions to lowest terms, when you're doing your final answer, when we start adding, subtracting, multiplying, and dividing, your answer must always be written in lowest terms, which means you reduce your fraction. Okay, so always practice reducing fractions. So again, does numerator divide into denominator? If not, try a different method. You might be able to look at it in your head and go, oh, I know what divides there. You might try the subtraction idea, or you might try the factoring idea, whichever one works best for you. In E and F, we have mixed fractions. So the instructions say reduce the fractions. So we are reducing the fraction only, not the whole number. So we need our whole number in our answer, but we are only reducing the fraction. So our answer, we're going to divide by 3, top and bottom. 9 divided by 3 is 3. 39 divided by 3 is 13. So our answer is 2 and 3/13. Okay, don't do anything with the whole number. The whole number needs to stay the whole number. Okay, so that's it for our class today. When we